So what we're going to do now is question 3. If you've got any questions at home or in the classroom, please do ask me. The question is dy by dx equals 1 minus 3 divided by x squared, and the x-intercept is 3. I'm going to write the key bits of information here, and then I'm going to switch off the board so that we can do the question. Now, the first thing we need to do with this question is we need to integrate it. So, if we're given dy by dx, often this means the first step you need to do is integrate it. So we get the integration symbol, and then we are going to integrate it. Just checking this is a 3 at the bottom. Can you put your thumbs up, Lance, if that's a 3? Great, thank you. So we always need to put a dx. That means we're integrating it in terms of x. The d is just a random letter, don't really know what it means. And then we're going to put an x because we're integrating it in terms of x. I do know what the d means, but you don't need to know what it means. Just remember to put it there. If you've got any questions online, just shout out. If it's a number, what you need to do is change it from a 1, and you're going to change it to an x. So if it was 2, that would change to 2x. If that was 3, that would change to 3x. Now, with the issue with this part is that the x cubed is on the bottom. Yes, Hugo?
I think it's not x cubed, it's s squared.
X squared. Yeah. Is it? Thank you so much. So this is actually x squared. Now, the problem with the x squared is that it's on the denominator. Now, when we integrate, we don't like anything being on the denominator. So we're going to move it up to the top. Now, Ben, what happens when we move the x squared up to the top? What?
You then have to divide it by the... So it becomes cubed, and then you divide it by the 3 as well, no?
Okay,
so
you're getting there, but...
divided by 3.
Say that again, Hugo?
So it should be 3x over 1 divided by 3, isn't it?
Okay, that's not what I'm saying. I'm saying if we've got an x squared on the bottom and then we move the x squared up to the numerator, what happens to the power of 2? How does it change?
It's a half.
Yeah.
No, it's not a half.
What?
No, what? There's something in front of the 2. What goes in front of the 2?
Negative.
A negative. Can you remember that now?
Yeah.
So we change that to a negative 2. So what we then need to do is integrate this. Does anyone... Sorry, my camera's gone off, 1 sec. Does anyone want me to explain how we've got from this to this?
I got it.
You've got it. Ben, have you got it? Aurelie, have you got it?
Yes.
Okay, that doesn't sound too convincing. Basically, Aurelie, if you have something like, let's think of something, 4 over x cubed, when you move the x cubed up, it becomes x to the minus 3. So if you ever move anything from the denominator to the numerator, it changes from a positive to a negative. Is that all right? You can't, apart from the fact you can't even see what I'm writing on the board, that would be really useful. There we go. So if we're changing from 4 over x cubed, the x cubed changes from the denominator to the numerator. You changes from a positive to a negative power. So now we need to integrate this. So the first thing we're going to do is we are going to add 1 to the power. So if we add 1 to the power, it becomes x to the power of minus 1. Because on a number line, if we have minus 2, if we add 1, it gets closer to 0, therefore it becomes minus 1. Can I have a thumbs up or thumbs down about that? Thumbs up. Thank you, Ben.
Yeah, I understood, yeah.
You understand that. But what else we have to change is we have to put this new fancy power we've got on the denominator as well. So this is going to go on the denominator, And we have to have what's originally there, which is the -3. And then we're going to have the plus c. Now we're going to tidy it up. This has a minus and a minus. Now the second minus, it doesn't matter whether it's on the denominator or the numerator. These two will combine to give what, Ben? These two will combine to give what? This minus and this minus.
Positive number.
Positive, thank you, Hugo. So these combine to give a positive. So we get positive 3x minus 1 plus c. So we've done the first part of the question. If you're given a differential function, if you're not sure what to do, integrate it. Now we're going to go on to the second part of the function question, which is to find this bit of information. Now it says that the x-intercept is 3. Now if we look at a graph, where it crosses the x-axis, what do we know about y? What's y equal to along the x-axis? So Lance just said y is equal to 0. So if it ever says x-intercept, that just means y is 0. If it says y-intercept, that would mean x is 0. Does anyone want me to go over that concept? No. So I'm just going to move the thing a little bit down. You are absolutely right, Ben. These do take a long time if you want to do them properly. Remember, if you make a mistake here, but you're really confident in the exam with the second step, you're going to still get your method marks. So don't just give up halfway through a question. Now we need to substitute these special numbers, 0 and 3, into this function. So we're going to say this is y equals. And because we've integrated, it goes from dy to dx to y equals. So y equals, we put a 0, and our x is 3. Then all we need to do is we need to work out what c is, either on the calculator or manually. Because of time and technology, I'm going to do it manually. Also, I prefer to do it manually. So we're going to do the following. 0 equals 3. Now 3 to the minus 1, we're going to just reverse this process we did earlier on. 3 to the minus 1, it just means 1/3. So we're going to move it from the top of the fraction to the bottom of the fraction. 3 over 3 just becomes 1. Any number over the same number just becomes 1. So 3 plus 1 is 4. So 0 equals 4 plus c. So c is equal to -4. That is our completed question. Right, in the chat, I'd like you to write whether you found that helpful or not helpful, or whether you understood or not.
I got x plus 3 over x minus 4.
Which part?
The end part. I got that at the end.
This bit?
No, but there's in the full thing x plus 3 over x, because you had 2 x's before. So when you make it -4, so it will still be -4, but you have the thing before it.
So you're talking about this bit here?
Yeah.
So yeah, this does mean 1 over x. Is that what you're talking about?
No, but the second part is because you'd have x plus 3
Yeah.
over x.
Yes. That's what I've done.
-4.
Yes. So what do you mean to
you have the 2 x's, so you can't. You still need to have them in the final.
Oh yeah, so the actual final answer, you mean, your very final answer is y equals x plus 3 over x minus 4. Is that what you mean?
Yeah.
Yeah, that's it. So I just didn't do the very last step.
Yeah.
So in the chat, please. Yes, Hugo.
Why don't we leave the x minus 1, x to the power of -1, like the -1 on the denominator, and and the other minus after x. No, like the other one.
This one or this one?
No. Yeah, that one.
Yeah.
Cancel out, right?
So this minus cancels out with this minus.
Yes.
Yeah. So those combine to give positive, and then you still have the 3, and you still have the x to the -1 here.
Oh, sorry. I haven't seen the minus one.
Is that all right?
Yeah.
Excellent.